Welcome back, folks. In today's class, I'll talk about measurements, and how the quantities are measured. So first of all, there are two types of quantities. One is scalar, another is vector. What is a scalar quantity? A scalar quantity has only magnitude, and vector quantity has magnitude as well as direction. So the perfect example will be if I say there is a car. This car is moving at 100 kilometers per hour. So it means I'm only talking about the magnitude of the speed. So car is moving at 100 kilometers per hour. So this becomes the magnitude. Notice I haven't talked about any direction. If I say a car is moving at 100 kilometers per hour in north direction, or maybe in south direction, 100 kilometers per hour in south direction, or west direction, or east direction, or maybe northwest, north and northeast direction. It can be any direction. Means if I'm specifying any direction with the magnitude, then that becomes a vector quantity. A vector quantity is represented by vector on top. So this is a symbol for representing a vector quantity, and in this specifically I'm representing a velocity. So this is the symbol arrow on top. So speed is an example of scalar, and if I add the direction with this, like 100 kilometers per hour becomes speed, and it is represented by symbol V. And now if I say a car is moving at 100 kilometers per hour in north direction, this will become a vector quantity, and this is called velocity. Same thing goes with the displacement and the distance. Distance versus displacement. Now, if a person has covered 10 kilometers, 10 kilometers, that's the distance covered by that person. Again, I'm not specifying in which direction he is covering this distance. Now, same person covers 100 kilometers in east direction. This becomes displacement. Now, if I see carefully, when we talk about distance, so if a person starts from here, he covered 10 kilometers in certain direction, and then he covered 10 kilometers in another direction, then he covered maybe 20 kilometers in another direction. I wanted to find out total distance covered by this person. So the total distance covered by this person will be equal to 10 plus 10 plus 20. So that will be 10 plus 10 plus 20. That will be 40 kilometers. Now what is displacement? Displacement is displacement is the shortest distance between start point and the end point. Now if I look at if I wanted to find the displacement for this given diagram, the displacement will be the person ends at this point. So this will be the displacement. This is what we have to figure out. Now I'm not going to find out what's the displacement in this cases because this is more of a two-dimensional problem. I'll try to make it a little more easier, and then we will be able to learn displacement in a better way. So if a person covers 10 kilometer in east direction, then he covers 15 kilometers in the west direction. So in the west direction he covered 15 kilometers along the same axis. Now what is his net displacement? We will say from the origin point he ends up here. So his net displacement is 10 east plus 15 west, and that will be equal to 10 minus 15. That gives me -5. Well, if it is kilometers, then it will be kilometers, or I can say 5 kilometers west. That will be the displacement. Same case, if I were to find out the distance covered by that person, distance covered by that person will be 10 plus 15. 10 plus 15 will be the distance. 25 kilometer is the distance covered by the person. So hopefully you are clear about the difference between distance and the displacement. Now I will elaborate onto this one. While dealing with all the scalar and vector quantities, you'll find, especially in the vector quantities, you will find we need to talk about the one-dimensional problem and two-dimensional problem, 1D and 2D problems. Now, what is the difference between one dimension and two-dimensional problem? So if I draw a navigation system, this becomes x-axis and this becomes y-axis. If the object is moving along the x-axis or along the x-axis or along the y-axis, that type of problem that type of problem is called as one-dimensional problem. Okay, so for example, in the previous case I was talking about the person moved in the east direction, then he moved back in the west direction. So it means he's along the x-axis. X-axis. Thus, this is an example of one dimension. If the person was moving in north direction, then he was moving back in south direction, again in north direction. So this is also an example of one dimensional problem. So basically, if we are measuring any quantity along the one axis, then that's called a one-dimensional problem. And now two-dimensional problem means that if we are measuring any quantity along two axes, for example, this person covered a displacement somewhere in northeast direction, okay, of 10 kilometers. This person is not only covering certain displacement in east direction, with respect to the east he is here, and with respect to the north he is somewhere down at this point, somewhere here. So he's covering the displacement in both the direction at the same time. So that's an example of 2D problem. So when there is a 1D problem, it's very easy to solve. You will just take the net resultant. 2D problem are a little more complicated, and we'll talk about the 2D problem later on. I just wanted to give you a glimpse right now. Now moving forward, I'll talk about the coordinate system and the navigation system. So this is east direction, this is the north direction, this is west, this is south. Now east we take it as positive, north we take it as positive, west we take it as negative, south we take it as negative. So if the object is moving along the south direction, we'll take his motion in the negative, I will consider it as negative direction motion. If a person is moving in east direction, we'll consider it as positive. Same goes with the north, positive. And if he's moving in the west direction, we'll consider as the person is moving in the opposite direction. Now, because we are dealing with the vector quantities, so we will try and understand some properties of the vectors. So one of the properties of the vector, which is really important to understand, that how we can draw a vector. So if I say 10 kilometers in east direction, now it is one way of representing 10 kilometers in east direction is you will start the origin point. This becomes origin point, and then you draw the arrow in the east direction. This is one way of representing the vector. Another way of representing the vector is you can represent this vector in any quadrant. This is first quadrant, this is second quadrant, this is third quadrant, this is fourth quadrant. If anyone doesn't know what is quadrant, so this is how we represent the quadrants. Now if this can also be represented as an east vector. This is also a representation of east. This is also a representation of east. What I'm trying to say, you can represent the vector in any quadrant, and that will, as long as the head is pointing in the east direction, that will be the correct vector. So all of them we can represent as 10 kilometer east. This also 10 kilometer east, any of these, this one and this one too. And this is called the collinear property of vectors. Now, vectors can be added and subtracted, as I said, along the same direction, as long as means along the same axis, shall I say. So as long as the vector is represented along x-axis, either east or west direction, you can add or subtract them. Or they can be in the north or in the south direction. They can be added and subtracted. And I've already told you, north will consider as positive, south will consider as negative, east positive, west will consider as negative. Now let's take an example for the displacement. A person covers a certain amount of displacement in east direction. Let's say this is 90 kilometers. And then in the opposite direction, he covers 110 kilometers, and then that is in the west direction. Then he covers certain displacement in east direction that comes out to be, let's say, 20 kilometers. Find the net displacement. Net displacement. That's what we wanted to find out. Net displacement will be sum of all these three displacements. Okay. Now, that will be d1 plus d2 plus d3. d1 is 90 kilometers in towards the positive east direction, so we'll consider this one as positive. Now d2 is 100 kilometers west, so I'll consider as 110 this one as negative, and plus 20 kilometers in the east direction, so that's why I kept this one as positive. So the resultant net displacement will be 0. So he'll be exactly at the same point from where he started. But if for the same question, if I ask you the distance, 90 plus 110, 90 plus 110 and plus 20, that will be 220 kilometer will be his distance covered. Okay, so hopefully you are clear about what is distance and what is displacement. Now, there is another formula for the displacement. That is v final minus v initial divided by well, not v final, sorry, I got distracted. So displacement is equal to d final minus d initial. That is a formula for displacement. Now, if we are only talking about a given individual vector, so person started from here, he reached here, and then what is the net displacement? So this is the starting point, he ends here, somewhere here, starting from 0, 0, ends at 80. Then I will use this formula. So that will be 80 minus 0, that will be 80 kilometer is the net displacement. If he started from 20, this is the point where he started, ends up at 80, 80 minus 20, that will be 60 kilometers, will be his net displacement. So that was the formula for net displacement. Now I'll talk about velocity and speed. Velocity. Velocity, as I told you, it is a vector quantity. The formula for velocity is d final minus d initial divided by time. So if I have to write the definition for it, you just have to write this formula in the equation form now, or shall I say in using the English language. So it is, well, if I see it, it is the rate of change of displacement with respect to time. That is velocity in a given direction. Well, because it is a displacement, so it will always be in a given direction. This is velocity. Now speed is distance covered over time taken. So this is a scalar quantity. Time is always a scalar quantity. We never measure the time with respect to direction. So speed is also scalar quantity. Now I'll take an example. If a car is moving, or car has covered, let's say 100 kilometers, or I'll use the SI units, 100 meters in uh, in 10 seconds. Find velocity. What I'm gonna say is 100 meters the car has covered. I'll also say east direction because I have to specify the direction for this. So 100 east. So initial point is not given, so I'll consider the initial point as 0. So divided by 10. So this will be, if I divide 100 by 10, that's going to be 10 meters per second in east direction. This number comes out to be positive. So thus it is in east. If this was not east, it was west. So I would have written it 100 west minus 0 divided by 10 and minus 100 divided by 10. That's going to give you 10 uh, negative 10 meters per second, and I can write it as 10 meters per second in the west direction. So that's how we will approach the velocity question. Now the final thing which I want to talk about for this lecture is acceleration. So acceleration is rate of change of displacement, not the displacement, my apologies, rate of change of velocity. Rate of change of velocity with respect to time. That is acceleration. For example, if a car is moving with the initial velocity of 100 meters per second and final velocity is 20 meters per second, we wanted to find the acceleration. And this is east, this is also east. So acceleration value will be equal to 100 east minus 20 east. Again, I haven't written the formula, so I'll write the formula down here. Acceleration equal to v final minus v initial divided by time. So time taken, I would say this process took, well, just to make the calculation easy, I'll say 20 seconds. So this will be divided by 20. So 80 divided by 20, this will be 4 meters per second square, because the unit of velocity is meters per second, and then you have to add another second on the bottom side. So let me write, this was meters per second, and the bottom there will be another second added, so it will be meters per second square for acceleration. This was velocity divided by time. That's how we can write down the units of acceleration. Now, if you see, I've made a slight mistake in this one. I should have taken the final velocity. It is final minus initial. So this should have been 20 minus 100. This will be negative 80. So negative 4 meters per second square. Negative 4 meters per second square, which I can call it as 4 meters per second in the opposite direction, west direction. So obviously, if the car is moving initially at 100 meters per second and then it is slowing down, it means the acceleration is the brakes are applied and the acceleration is happening in the opposite direction. This is 20 meters per second. So hopefully you got an idea about the basics of acceleration, velocity, and displacement. I'll see you in another lecture. And if you think of subscribing it, that'll be great. And I'll see you later.